Hello and welcome back to Kerbal Space Program. In the last episode, we had our first space tourist go up into space and come back safe and sound. It was Tito. He's still celebrating his accomplishment, but it's time for us to move on. And I believe these are the contracts we have right now. I did say I was thinking about doing these, but you know what? Let's go to the moon. Let's explore the moon. We're going to send a probe to the moon. There's just too much cash here to ignore and science. This is 30 science plus whatever I get from experiments. So I think now is a good time to do this, and this will unlock other types of contracts for us. So let's build a rocket and at least a probe to send to the moon. Okay, first, I'm looking at the KSP Delta V planner, and it looks like I need to get from Kerbal surface to low orbit. I need about 4,000 Delta V, 4,000 meters per second, and to get from the surface to low orbit, moon orbit. I'm not sure I want to go into full orbit, but we're going to need 5,300 meters per second. And then to come back, low orbit to low orbit, about 340. So about 6,000 meters per second. So let's start with that. Let's send the probe here, Probodobodyne Octo, and we're going to need, yeah, I guess we'll need something like a cargo bay, a little tiny service bay. I'm thinking we're going to need some electricity. So let's put some solar panels on here. We're going to need some batteries. This one, I'm thinking a couple of these, 200 electric charge. Actually, 100 should be enough. Because we're not going to do any transmitting. I'm going to bring the probe back. So, and then we're going to do a couple of experiments. We're going to wait when we send our scientists there. But for now, we're going to do, oops, I just need 2 of these. So 2 temperature experiments, batteries. You know what? I might need a reaction wheel. I don't know. I'm going to use the gimbal engine, but I'd like a little bit more control. Forgot where they are. Are they? I know they're here somewhere. Here we go. Small incline reaction wheel. Used for a series of spinning discs that are going very fast to generate torque necessary to control spacecraft without wasting any propellant. Let's put that right here. Stack that on top of the battery. Close that. We need a parachute to bring this part back. We'll need a heat shield. And let's see, this one's 300, this one's 300. That's 150. This one's small though. Okay. Next, we need, let's see, how much delta V do we need to go from low orbit to moon low orbit? about 1,290. And then to come back, another 300 more. Let's put... I like... Oh, that's the messed up fuel tank. Never mind. How much Delta V is this going to have? We're going to use the Terrier. Oh, I have this new engine. Oh, that's a jet engine. Sparkler. ISP and vacuum 345. And this one's 345 as well. So that gives us 2,100 Delta V. That should be enough, but just in case. Just in case. I'm going to put on a slightly bigger... Oh, I need a decoupler. This one is 1 ton, 0.4 tons. Costs 400. This costs a zip. 250. How big? How much does this weigh? Quarter ton. Let's just use that one. There we go. We're sending this right here to the moon and back. And we have 2,800 Delta V. That should be plenty. Probably too much. I mean, a lot more fuel than we need, but I like to prepare. Alright, so next we need a stage to get us into orbit. So let's put another decoupler. And a couple of larger fuel tanks. I'm thinking this one. A couple of these. This should get us... Let's find out. And what engine do we want? Probably the swivel. Because I'm going to put a few solid rocket boosters here. This stage gives us 2,400 Delta V. So to get from surface to low orbit, it's 4,000. This gives us 28. And we need a few, probably, SRBs. I'm thinking about these here. So let's put a few of those on. I like these Globe 5s. That looks about right. A little bit lower down. I can't seem to... Oops. Maybe I should move these down just a little bit. Alright, one of these days I'll get it right. I think that's it. Yeah, those look straight. Alright, so that gives us... That was stage 6. This gives us... 3,500 Delta V. 3,500. Plus a little bit from this stage will get us into orbit and get us to the moon and back. So this should be plenty here. So this is our rocket. Let's call it the... What? What do we have? Oops, let's save. Titan. Let's call it the Atlas. This is going to be lunar probe. Well, mooner probe. Okay. And I think we're good. Let's check our staging. We want these all to go first, decouple, and then when this stage runs out, decouple, ignite this engine, and decouple here and parachute back. That looks good. So we're just going to the moon. We're going to go into high orbit and then low orbit, get temperature readings on both, and just come back. We're not going to land. So I think this should do it. Let's take it out and see what we can do. Let's go. Alright, let's check our staging. We have solid rocket boosters and the main swivel, liquid fuel engine, decouple. This looks good, but you know what I forgot? I need some fins on this thing or it's going to spin out of control most likely, so let's go back and put them on. Alright. Thinking these Delta Deluxe. These look pretty good. They give us plenty of interaction. There's a lot of surface here, so that doesn't look right, does it? Nope. So there's a lot of surface area, so it'll give us lots of control. Right about there, I think. Alright, let's save that. And let's go out again. Let's get to the launch pad. Alrighty, let's check staging one more time. Both engines, and we're at about 40% throttle. That should be good for our liquid fuel engine. We're going to decouple here. We're going to ride this out to orbit, decouple, light that engine, and decouple here. When we come back in, we look good. Let's hit our stability control, and let's go. I'm going to start turning over probably now, I guess. Let's see if this thing starts rolling. Not too bad, not too bad. It does want to roll a little bit, as you can see. Alright. So ditch those and throttle up. And those things collided right as they detached, and I think right now we want to start turning over. Let's look at the map. Yeah, we want to get turned over really quick. Let's see if we can go almost horizontal. And I'm going to kick this up a little bit. There we go. Try and get a little bit more distance here. I might go a little higher than this. About 85, I think. There we go. Now, how much fuel we got left? We got enough probably to get in orbit. Let's see. Let's add our maneuver. Orbital insertion, burn. $84, $91. I think that's going to be okay. 83, 88. Good. All right. So our burn is in 1 minute. Let's see if we can turn the spacecraft. get lined up on the burn vector right here, the blue marker. So we're going to start our burn about 18 seconds, T minus 18. Alright, that looks good there. So we may not have enough fuel in this stage to get into orbit. We'll just use what's left, a little bit of this tank. Alright, let's go. Full throttle. Yeah, looks like we're going to have to dump this one. We might as well do it now. Well, that was fun. All right. So we got 83 and 89. Looks good. So I don't know why that didn't break away. That was kind of interesting. That decoupler didn't seem to work very well. But we are now safe in orbit. So let's see if we can go to the moon. The moon's right here. So let's mark it as target. And then see if we can get a encounter. Let's put it over here about 90 degrees. And then we'll put our maneuver, well, about 90 degrees from the moon's orbit, right about here, I guess. Let's turn this a little bit. There we go. And push our apoapsis out, see where we're going to get our encounter. Okay. A little farther. Moon periapsis. 301. 216. 141. So I'm trying to get a little closer. 53, that's good. A little closer. 8,700 meters, that's a little too close. 15,000, that's perfect. Alright. So it's 47-second burn in 4 minutes. Let's move our spacecraft to the burn vector. The Mooner Insertion Burn Vector. Right there, that blue marker. Alright. So we're going to burn for 47 seconds. So we'll start our burn at 25-ish. T minus 25. And, looks like, are we getting charged? We are getting charged. Okay. So we've got our solar panel pointed towards the sun. That's why I like to put 4 of them on here, so I don't have to keep rotating the spacecraft all the time. Alright, let's do a little bit of time acceleration. Make sure I'm right on that marker. Alright. So there's the moon. Alright. So I said 25, about 26 sort of seconds. $23 more like. Doesn't have to be perfect, but... So again, half the burn time in front of the node and half on the other side. Then when we get close, we're going to push our apoapsis up, like we saw here. When we get close, we got to slow down so we don't overshoot it. Alright. Ready to burn. And full power. And we got plenty of liquid fuel. We should easily make it to the moon and back. Adjust my vector here slightly. Alright, here's where we start wanting to think about slowing down so we don't overshoot. Well, I overshot just a little bit. So we got a moon periapsis of 2,400 meters. We're probably going to have to fix that. So let's turn our spacecraft around and burn on this vector. Basically, what do they call it? We're basically slowing down from what we just did. Whoops, now I went too far that way. Let's turn back to here. Burn just a tiny bit. Okay, what do we got? 9,000 meters, I think that's good. That's good. Alright, so our encounter, our moon periapsis is 9,000 meters. That's as close as we're going to get to the moon on this burn. We might adjust it, I don't know. Let's do a quick save real quick. Just in case. Okay, we're on our way. I had to reload a save. I accidentally went a little too far, couldn't correct. Well, I made a slight miscalculation over here, and I wanted to go back to the save because I messed up, and I thought it'd be easier just to go back to the save, the quick save, right after I made it, and do this real quick again. So let's time warp out to our destination, where we're going to come into close contact with the moon. And our periapsis is 10,700. Okay, we should see the moon coming up close behind us. There it is. There's Kerbin. And we're going to swing out here this way. The moon's going to come this way and then grab us. We're going to be in front of it, and it's going to push us around. Basically, we're going to be here. The moon's going to be here. We're going to be here, and it's going to grab us and pull us back towards it and out this way. Right here. So, let's watch this happen. I should probably make sure I'm aligned and getting electrical charge. Which it looks like I am. Okay. Alright, so here's what's going to happen. Again, our probe's going to sit right here. And then when we get right about here, the moon's going to be right about here or so. And then the moon, we're going to be in the moon's sphere of influence, meaning that its gravity affects us more than Kerbin's, and it's going to pull us towards the moon. And then, like this, it's going to pull us towards the moon, and then we're going to go around the backside, and then we're going to, after our encounter with the moon, as the moon continues, it's going to throw us out here, and then Kerbin will, again, take over, affecting our probe. Basically, Kerbin's gravity will then take over as the dominant gravitational force, affecting our probe. So then the end result is this orbit right here. So let's go back here and wait and watch the nav ball flip, and then we'll know that we're in the moon's sphere of influence at that point. Then we can do our first temperature study. Ah, there it goes, right now. So let's go back to here, and now as you can see, it's now starting to pull us towards it. The closest approach will be 10,702 meters. And then it'll send us out over here, at which case, once we reach this point, we'll wind up in this orbit around Kerbin again. So all we have to do now is do our first temperature study. Alright, temperature scan while in space high over the moon. Measuring the temperature of space appears to be quite impossible, as there is no matter around to be either hot or cold, except the spacecraft and the thermometer itself. This is probably going to give the R&D guys something to think about for a while. We've got 16 science for this. We're going to keep that experiment. And this temperature study, is going to be when we're closer into the moon. So we have to wait for that. And I believe you'll know when you get closer, when you change from high orbit to close to the moon, the camera will switch. It'll rotate your spacecraft, I believe. Okay, we're at 38, 37, 36. We're getting closer and closer and closer. As you can see, this is why we're going to be kicked up in an out of the moon's yeah, let's go back here. Plane. You can see the plane. This is the lunar plane as this is its orbit around Kerbin, and we're going to be kicked up into this orbit again because we just happen to be approaching the moon down here, and as it pulls us, it's going to pull us up in this trajectory. We're still 140, 130. There we go. Now we're in the low orbit of the moon, so we can do our other experiment. Where is it? Is this one? That's high over the moon, so we want to do this one over here. Log temperature. Temperature scan while in space near the moon. So we get 24 science for that. Keep that experiment. We can now close these doors. And let's make sure. Okay. Charge looks good. Let's go back out to the map and watch. Well, actually, let's watch the moon fly by. As we get closer and closer to our closest approach. And now we're starting to go away. Let's do time warp. I'm a little paranoid about. Let's turn this to make sure that we're. Oh, we can't. Now we have full control. Let's turn this so that we know that we'll have electric charge. There we go. Just don't want to run out of electricity. It's a bad thing. Okay, as we hit this, we'll go up this way. It looks funny, I know. How is it that when we get over here, we're going to wind up in this orbit? Well, this, as you can see, is moving down. We're actually moving very slowly. And this will, when this meets this, then we'll be in this orbit here, around Kerbin. And I don't know. You know what? I didn't put a antenna. Did I already say that? Didn't put an antenna on this probe, so when we get out to here, I don't know if I'm going to be able to do the burn. Okay, now we're in this orbit. We're now in Kerbin's sphere of influence again. So let's see. I'm going to do the maneuver here, but I don't think I'm going to be able to do it because I'm going to be too far out. Too far away from Kerbin. So I stupidly didn't put an antenna on this probe. 17. We want to get it around 25,000 meters. Oops, that's way too... See, if it's 9,000, well, there's just not enough... Well, we're going in too steep, and there's not enough atmosphere to slow us down. And we'll crash into the planet before we slow down. Okay, 25 is good. If it's too high, we'll just zoom through the atmosphere and then and then go around again. We won't slow down enough to go to land. That should be good. Now the question is, will I be able to control my probe out here? I doubt it. Let's time warp and see. Limited probe control. Can I still move my probe? No. Yeah, I figured that was going to happen. Okay. So what we'll do then is I'll wait till I get over here and get probe control again, and then I think this is what's going to happen. Get over here, get probe control, do a burn so that I can lower my apoapsis down to about right here, and then when I come back around again, then I can do my deorbit burn. So let's see how that works, because I don't think I can do a deorbit burn from here. So this isn't going to work. Oh, I can't delete it because I don't have control. Right about here somewhere, I'm thinking. Close to the... I should be getting probe control soon. I think right about here. Okay. Oh, I have it back, it looks like. Let's test. Yes. Yes, okay. Let's make sure I don't lose electric charge. Okay, so let's put a maneuver here. Well, wait. Where am I? We need to... There we go. Get rid of that maneuver. Put one here. Right about there. So I'm changing my orbit to this. And then when I get back up here to apoapsis, then I can I wonder if I could deorbit now. I don't think so. Maybe. How much fuel is this going to use? It's only a 13-second burn. I could probably do that. $109. Let's get that down to 25-ish. 35. 29. Too steep. 20. 20. Come on. 26 is good. Maybe a little higher. Tiny bit. 28. That's good. Okay. So we have a 13-second burn in 1 hour. Let's orient our spacecraft. So we're looking in the proper direction. We're going to burn in the proper direction, which should mean engine facing towards Kerbin. That will slow us down. Okay, I'm losing bad charge now, I think. No. I'm still getting charge. Right about there. Okay. One hour to burn. Node. Let's fast forward a little bit. So when you're out here, you got to be careful to always point your spacecraft towards the sun, because if you don't, you'll find out that you lose power as you go through, and you're maneuvering your rocket around, and then you'll run out of power, and then you're stuck. Can we go a little faster? Okay, we'll start our burn at about 6 seconds. And it's going to be, I'm not going to do full power. I have to be careful. I don't want to go too, I can always correct the burn though, so. If I go a little bit too far. And the way you do that is you just turn around your spacecraft and burn the other way, the opposite direction. Okay, here we go. Start slowing down. I'm watching that top number. Right there. 27. Perfect. So our periapsis is 27. That should deorbit us. All right. So let's zoom ahead. Let's make sure that our spacecraft actually is, again, turned towards the sun, so we can get some solar power. There we go. So if you're facing away, you'll see this number is actually positive, meaning you're losing power. See it going down a little bit. It should be going down. There we go. If it's facing towards, if one of your panels is facing towards the sun, this will be a negative number. And your power will be restored to your battery. Alright, let's leave it like that. And time warp. I don't want to go too fast. I'm afraid I'll zip right through it and burn up in the atmosphere before I have a chance to react. Alright, we'll probably slow down a little bit. See where we are. Surface speed, orbit speed. We're focus on the Atlas. Let's focus on Kerbin. Oops. Slow down. I'm looking at out there we go. There's my altitude. Okay. Re-entry in 9 minutes. And our periapsis is 27. That should be good. I'm going to quick save again because it saved me last time. Just in case I screw up it should be fine, but just in case I do something stupid, like I did just a few minutes ago. Okay. We could dump this. I'll leave it until we get closer. Okay. Turn this towards the retrograde vector. And just wait. Now we just wait. So we don't have a panel looking at the sun, or trying to collect power from the sun, but we're at full charge, so we should be okay. All right, let's get down there. Whoa, that was quick. So it says I'll exit the atmosphere. If you see this going up, then chances are you're not going to go through the atmosphere and then continue in your orbit. Yeah, see, it's going up, which means we're not going to exit the atmosphere. We just need this thing to slow down to below 1,000 meters per second. It's going really fast. I should turn up the volume on the effects a little bit. It sounds a little... I wonder if I could do that now. Ambience, is it ambience? Spacecraft. And ambient, not ambient. Yeah, I think it's ambient. Let's see. Yeah, that's better. I don't need the contract list up. Alright, we made it through the atmosphere. We're slowing down. We're on the dark side. But as soon as we get below 300 meters per second, we'll deploy the chutes, parachute down, recover, and we will have finished our first moon flyby. What does our contracts look, by the way? Fly by the moon, gather scientific data, and recover, transmit, and return. So these should be checked by the time we land. Alright, let's do time warp. I don't know where we are. Let's see. Looks like we're over the ocean, maybe? Yeah. Alright, closing in on 300 meters in height. Surface descent speed looks fine. And splashed. Alright, let's recover and see what we've done. Looks like we've got milestones, completed contracts. This looks good. Alright, so we earned 52 more science, some for the experiments, and some for just doing the contract. We 3,700 funds from recovered parts. And let's take a look at our achievements. Most complex vessel launched. Here's the milestones. Broken the speed record. Initiated the first flyby of the moon, and we get, science and cash rewards for this too. Escaped the gravitational influence of Kerbin. Escaped the gravitational influence of the moon. Returned home from a flyby of the moon. Gathered the first scientific data from the moon. And that gives us a bunch. Wow, I think we had... I don't think we were even close to that amount of cash before this mission. Talk about any closer, and there'd be paperwork. Of course, because we got pretty close to the moon. Explore the moon. A return trip from the moon. Is this mission log right? Incredible. Excellent. First return from orbit of moon achievement. More explore the moon goodies. Taking our first steps toward exploring the moon. This is the contract, I believe. So those were our milestones, and yep, we have our contract here completed. Let's take a look and see what else we got. Available. Anything interesting? What is this? Explore the moon. We'd like you to go to the moon and stay there in a nice stable orbit. It isn't personal, it's science. So what we would do is just go into orbit around the moon and then return. Of course we're taking that contract. When does it expire? 4 days? Doesn't matter, we're taking it. Yeah, Gene's all happy about that. What else we got? This is all stuff on Kerbin, which I might do at some point. I'm not going to record it, but we'll see. Okay, advanced piloting for who? This is Jebediah again. This is the inclination change. I might do that later. I don't know. So this one wants Bob, scientist, collects science at Kerbin's tundra, flying low, and do an EVA report. I don't think so. Magnetic environment around Kerbin. So we need to enter an orbit with 0.16 eccentricity, 20% inclination, and it wants these experiments on board. Ionization scan. Enter orbit around the moon. Conduct ionization scan. Time for completion 15 minutes. Have part type ionization chamber. I'll have to look and see if we have that part. What else we got? Temperature surveys of the moon. So this would be, basically we have to get into orbit and be above these certain sites. That would take a while. It can be done. It could take a while. Temperature surveys. This would be good. These two would be good at the same time. Bring one tourist over where? Suborbit above 70,000. The southern mountains. The Great Desert. Bring one tourist to low Kerbin orbit. Is that all? Orbit, periapsis above. Yeah, we could do that. It doesn't give us a whole lot of money though. So I'm still looking for the rescue Kerbin contracts. Rescue astronauts. I don't see any yet. Hopefully the mods I have doesn't take those contracts away. We'll see. I think we'll do these next. I'm going to leave it here. I think this has been going on long enough. So I'm going to leave the episode here. We'll probably do these two next. Maybe this one as well. We'll see. Hope you enjoyed this episode. Thanks for watching. If you liked, like it, and subscribe, and come back and see the next one. And I'll see you next time. Have a good one.